record, shucks. Finite is going to look like this. You'll have a first term, you have a last term. Yes, there are ... dots, but there's something after the ... okay? It's if they have a ... at the end, like, just keep going, that's when it's infinite, okay? If there's a number at the end, it is finite, it has an end. The formula for a finite geometric series is this. The sum of however many terms, right, n is your number of terms, that's here, is the first term times, and this is so hugely important, right? You have to use parentheses on this. So you're going to start your parentheses. It's going to be 1 minus the rate to the nth power. Then you have to finish that parenthesis. If you don't, you will not get the right answer, okay? Make sure you finish off that parenthesis and then divide by 1 minus your r, okay? You're welcome to break it down into pieces and then divide at the end, but I think it's way easier if you just plug the whole thing in your calculator with parentheses, okay? So a sub 1 is the first term, that's nothing new. R is the common ratio, nothing new. N is the number of terms, nothing new. So really it's just, here's a new formula with all the things you already know, plug them in, okay? So this one says evaluate 3 plus 6 plus 12 plus 24 plus 48 plus 96. Now, could you just plug that into your calculator? Yes, right? You could plug in 3 plus 6 plus 12 plus 24 plus 48 plus 96. And on a problem like this, it's going to be quicker because it just is. But I'm using this one just to show you a good example of how it works in the calculator, okay? So we're going to do it in the calculator, but yes, you could absolutely, sorry, we're going to do it in the formula. You could absolutely plug it into the calculator. Or you could use the formula I'm going to show you. So the first thing you got to make sure you check here is this arithmetic or geometric? Okay, now I'm teaching you about the geometric ones today. Yesterday we did the arithmetic, but on the test, I won't tell you, like, here's a geometric one, here's an arithmetic one. You have to know which formula makes sense. Okay, so here's how you identify arithmetic versus geometric. Actually, you tell me, because you should know how to identify arithmetic versus geometric. What do you do? Geometric, how do you know? You're multiplying, right? If you're multiplying to get to the next thing, okay, that is going to be a geometric formula. So right here, you should go, ooh, I need the geometric version, not the arithmetic version, okay? The one we did yesterday was arithmetic. Dividing would be geometric too, yeah. It's essentially multiplying by the reciprocal of the number, right? Okay, so we know this is geometric because we're multiplying by 2 each time. So we're going to use this geometric formula, okay? So it's the sum. What is our n right now? The number of terms, which is what? There's 6 of them, right? 3, 6, 12, 24, 48, 96. So n is 6, okay? What is your r right now? 2. The common ratio is whatever you're multiplying by. So your common ratio is the 2. And what's your a sub 1? That's your 3. Okay, so that's everything you need to plug into this formula. So we're going to say s sub what? 6 equals a sub 1, which is the 3, parentheses, 1 minus 2 to what power? The 6th power, your n. End that parenthesis. Then divide, parenthesis, 1 minus your 2 again. Okay, now get your calculator out and plug that in and make sure you're getting the right answer here. Tell me what you get. There's 6 terms. 1,
Oh,
2,
got
3,
it.
4, 5, 6.
Thank you.
Yep. What'd you get? 189. Good. If you're not getting that, talk to me after the lesson and I will help you plug it in. Okay, so example number 2 here says find S sub 10. So in this problem, the things we need are N, R, and A sub 1, okay? Because we can tell right now this is what kind of formula? Okay, so this looks infinite. We're going to find the sum of the first 10. So we don't need to worry about the fact that it would be infinite. We're worried more about the geometric versus arithmetic. This is geometric, right? Because we're multiplying by what? By 3. Okay, so we know it is geometric because we're multiplying by 3. Do you know N? What is it? 10. It's 10, right? They said S sub 10. That means the sum of the first 10 terms. What's R? 3. What's A sub 1? 4. So we're going to say S sub 10 equals, and now plug it into the formula. A sub 1 is our 4, parentheses, 1 minus the rate, which is our 3, to what power? To the 10th power, divided by one minus 3. Plug that in. What do you get? 118,096. Did you get that? Okay. Easy peasy, right? Okay. Example 3. They give you summation notation, and they tell you to evaluate. What are your options here? What could you do? Plug it into your calculator. Math 0 or alpha window 2. Okay? I don't care which one you use. They both work. If you have an 84, I'm not sure that they both work, actually. 83. How much? 62. Yeah. So you can plug it into your calculator. What's the other way you could do this one? What? What's your first term? 2. 2 to the first power, right? You could do 2 to the first plus 2 to the second. How high am I going on my exponents? 5, yeah. Oops. So you could do that. Just plug it into your calculator. 2 to the first plus 2 to the second plus 2 to the third. It's a lot more work. I wouldn't. I would just plug it into the calculator like this. But if you don't love that, plug it in the other way, okay? All that to say, calculator's fine. You get 62. Any questions on that? Okay, so that is for a finite series. Now, you guys mentioned it earlier. I just want to reiterate this. Is this a finite series? No. What made it so that we used a finite formula?
We were just looking for the 10.
We were only looking for the sum of the first 10 terms, right? They told us find the sum of the first 10 terms, so that is finite. We're not finding the sum to infinity. We're finding the sum of the first 10, okay? Keep that in mind. Infinite geometric series. Oh, what is that little circle doing there? Do you guys have that on your notes too?
Yeah.
Huh. No idea where that came from. I wonder if that's going to be missing. Oh, it's the bullet. It's the bullet. That's weird. It's not on my notes. Must have adjusted things and it shifted. Oh, I know why. Because it's not actually a bullet. I had to make it something different. Okay, good to know. Infinite geometric series. So geometric in that you're multiplying by the same thing every time, okay? Infinite because it has this. If there is a ... at the very end, That means this just keeps going, okay? Now let's think about that. If I take 5 plus 10 plus 20 plus 40 plus 80, and I want to find the sum of that geometric series, any thoughts on what our sum is going to be? If it keeps going forever, infinity, okay? Your sum for something like this is infinity. That's your like figure 8 on its side, right? What's your common ratio? A 2, right? So we're multiplying by 2, but if the number is constantly getting bigger, it's going to go to infinity if you just keep multiplying by 2, right? It's going to keep getting bigger and bigger and bigger and bigger and bigger forever. Now look at the next one. You have 1, and then a half, and then a fourth, and then an eighth, and then 1/16. You just keep multiplying by a fraction, okay? So I want to give you a little visual on this one. If you think of this in picture form, this is 1, right? That is a complete circle. If I'm going to add to that a half, that would look like that, right? Now I'm going to add 1/4. So it would add this. Now I'm going to add an eighth. So it would look like that. Then I'm going to add a 16th. So it would look like that, okay? If I keep going, right, this is an infinite geometric series. My sum, any thoughts? It's 2. Now, people are always like, no, it's never going to hit 2. But if we go to infinity, right, the sum ends up being 2. Now, it's kind of a tricky thought because it just keeps going, okay? But it's going to keep going through to 2. It's a weird thought, I know. What is your ratio, your common ratio on this one? 1/2. You're multiplying by a half each time. So here's what I want you to see. This goes along with this down here. When your common ratio is a number that is greater than or equal to 1 as a absolute value, okay? The absolute value of your common ratio, if it is greater than or equal to 1, your sum will always be infinity. Because if it's more than 100%, it is constantly growing, right? 1 always represents 100% of something. So your sum is going to be infinity. But if your common ratio is a number, the absolute value is a number less than 1, so a fraction, if you will, right? A fraction of 1, then you'll actually get a sum from it. So keep that in mind. We call this converge, and when it goes to infinity, we say it diverges. If you think of like, if someone diverges, it's kind of like, well, they went off into like forever, right? They were going on this path and then they diverged and it was like gone for good. Diverge, okay? So think diverge goes away, infinity, forever. Converge, like coming together, converge, okay? That's the one that's going to have a sum. So converge versus diverge, try to think in your brain what that means, and you should be able to come up with which one is which when you're solving these problems. Questions on that before we check what converges or diverges? Okay. So really when they ask you, does it converge or diverge, what's the only thing you have to look at in the problem? Your R, right? R will tell you, does it converge or does it diverge? So take a look at this. Does it converge or diverge? To get from 2 to 2/3 and 2/3 to 2/9 and 2/9 to 2/27, what are you multiplying by? 1/3, right? If you're going to multiply by 1/3 each time, is that going to converge or diverge? If your rate is 1/3, your common ratio, you are going to converge. Right? When it's a fraction, you will actually get a sum because you keep adding until you get one complete thing, okay? All right, look at example 5. So this is in summation notation. Where's your R? This was a few days ago where you saw the formula in this setup. What one of those numbers represents your R?
4.
It's the 4, right? A sub 1 times R to the n minus 1 power. That was one of our formulas. This is R. So is that going to converge or diverge? Diverge, right? If I'm multiplying something by 4 to some power over and over and over again, that's going to get huge. It's going to just keep growing, okay? So just remind yourself, all you need is the R. Look at the R, converge or diverge. Okay, one more formula for you. So in an infinite series, if it converges, then you get the sum to infinity will be your first term divided by 1 minus r. And again, parentheses matter, okay? Start the parentheses here. If you don't, you're going to get weird answers. And we're just going to do 3 problems that use this idea, okay? Notice in an infinite series, how do I know that this is an infinite series, number 6? It has that infinity symbol right at the top, right? Our last term is infinity, so it just keeps going. There is no last term, right? Infinite. So I know this is this formula because I see that infinite symbol there, okay? So I'm going to say this one, the sum to infinity. What is a sub 1? It's 1, right? If I take my number 1 and plug it in for n, I'm saying 1/5 to the 1 minus 1 power, which is 1/5 to the 0 power. What is anything to the 0 power? It's 1, right? So I get a 1 on top for my a sub 1. On bottom, it's going to be 1 minus, what's my r? It's the 1/5. This number is your r. Whatever is taken to the n minus 1 power is your r, okay, every time. So this is 1 minus 1/5. Okay, now plug that into your calculator because I want to make sure you're plugging it in correctly. So the sum to infinity is what? 5/4 is one way to write it. What is 5/4 as a decimal? 1.25. Yeah, I don't care which one of those you give me. I feel like most of you are going to plug it into your calculator, so it's going to tell you 1.25. But 5/4 is the same thing, so you could do that also. If you're not getting that when you plug it in, talk to me right after this, okay? We got 10 minutes. I can walk you through the calculator. Okay, number 7. First of all, take a look here. To get from 1/3 to 1/9 to 1/27, what did you have to do? Multiply by 1/3. So this is a geometric series, right? Because we're multiplying. Is this finite or infinite? How do you know it's infinite? Dot, 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 right? If there's dot, dot, dot at the very end, then it is infinite. Okay, so you're going to have all these formulas that we've learned. You're going to say to yourself, I need the infinite geometric formula. That's going to be the one, it's the only one that has infinity in it. Okay, so when you know it's infinite and you're trying to solve, you're going to use that one. Yeah.
So we've only done geometric so far, right? Like
We did arithmetic yesterday.
Oh.
Those were arithmetics. We were adding the common difference, right?
Oh, yeah.
Mm-hmm. Yeah, so those are the arithmetic ones. Okay, so if we take this formula, let's just rewrite it here so you see what I'm plugging in. The sum to infinity is your a sub 1 over 1 minus r. It's a nice formula, right? It's a pretty simple formula. So we're going to say the sum to infinity. What's your a sub 1? It's, okay, ooh, is it 0.3? 0.3 is 3/10, right? 0.3 repeating is 1/3. So make sure you write it as 1/3 divided by 1 minus, what's your R? 1/3. This 1/3, right? This one's the R, this one's the A sub 1. So 1 minus 1/3, don't forget your parentheses. Plug that in. Oh, were you giving me your sum here? Oh no, that's not this one. What did you get? You get 1/2. Okay? Or you may write that as 0.5. So you plug it into your calculator, you get 1/2, 0.5. Notice you came up with a number, right? It converges. You got a sum from the sum to infinity. That's a converge. Okay. Oh, we're up here. Last one, example 8. We have to figure out, is it arithmetic or geometric? How do you figure that out? I feel like this one confuses people a lot because it's not just as intuitive as some of the other ones. Remember, you always take the second term and the first term and do something to them. So you either divide them or you subtract them, right? So if I take 0.03 and I divide by 0.3, okay, I get 0.1. If I subtract them, 0.03 minus 0.3, I get a negative 0.27. Okay, subtracting. So that would be arithmetic. Geometric would be dividing them. I get 0.1. What do you get if you do it this one to this one? Are you going to get the 0.1 dividing or the 0.27 subtracting? The 0.1. If I divide 0.003 by 0.03, I get 0.1. So this right here, this work, is what tells me this is a geometric series, right? The second number divided by the first, the third divided by the second. If you get the same number when dividing, geometric, okay? So now I know it's geometric. Is it finite or infinite? It's infinite because it's got that ... So an infinite geometric series is this guy. So it's the sum to infinity. What is A sub 1? 0.3 divided by, parentheses, 1 minus, what was our R? 0.1. So you plug that into your calculator, and your sum to infinity comes out to what? 1/3. Yeah, 1/3, 0.3 repeating. Don't tell me 0.3. That's not 0.3. If you say 0.3 repeating, sure. But 0.3 is 3/10, not 1/9, right? So just be careful with that. Can I just show you something with this one real fast because it's cool? If you think about this adding vertically, right? If I add these all together, look what happens. It's just going to keep going, right? 0.3 repeating. So if you get stuck, you have an option with one like that where you can just see what the pattern is that's happening. 0.3 continually is going to be 0.3 repeating or 1/3. Okay? Questions on that? Chapter 9. You made it. Monday, we'll go over questions from this. We're going to do a review together. You're going to do a review. Chapter 9, you guys, is a lot of formulas. Okay? At the top of the review is all of the formulas. At the top of your test is all of the formulas. The tricky thing is, I don't tell you what any of them are for. So you need to know when to use an arithmetic, which one is arithmetic, when to use a geometric, which one's geometric. How can you tell the difference between an arithmetic and a geometric formula? R and D, right? If R is in the formula, it is geometric. If D is in the formula, it's arithmetic. Okay, so look for that. The pictures, the formulas tell you a lot. So if you just stop, think about what you got going on, you can figure out which formula to use. We'll talk more about that on Monday too, but that's it.